Okay, so we are in lecture number 6. You can access lecture notes through the models and also the recording on the YouTube playlist. Last time we covered the methods, how we can define the methods, signature of the methods, some preconditions, and we discussed how we can read the API and extract some useful information from the method API. And the lecture number 5, most of it was like a review and discussing all what we covered. There's no new topic except the JUnit test. And the JUnit test was not included on the lab test 1, but it will be included on the lab test 2. Today we're gonna look at the very powerful, I can say, tools. It's called control structures, which is allow you to control the flow of execution of the statement. So far we are seeing the sequential execution of the program. So first statement should be executed successfully, then we have a second statement to be able to go to the second statement. But now we can see how we can selection of the executions. We need to execute a certain statement and avoid executing another statement based on some kind of conditions. And we're going to see how we can repeat executing some certain of Java statements. So for some of you, and I think most of you, this is more like a review for your prerequisite when you finish your Java script course. You know all these if statements, if else statements for loops. So there's nothing new in that. So we're going to try to look at these in Java point of view. So we look at all these structure statements, for loop, if statements, if else statements, switch statements from the Java perspectives. And also we're going to see, because we have a primitive data type and we have the object data type. And we need to compare between a primitive data type and object data type and how we can incorporate this with the control structures. And hopefully we are able to discuss the random number generators and then exceptions. I think exception is it will be up before, when I write this outline, it was based on the last semester. So I think now exception will be jumped to the beginning. And then finally we're going to see array. In case if we didn't complete all these topics today, it will be part of the next lecture after the reading week. But before I jump to discussing more detail about Java control and Java repetitions statements, I'm going to discuss a Trussing API, which is allow you to generate a message for your apps. So in case of you are seeing something abnormal in the execution or the user enter invalid values to your app, you need to let the user know that there's something wrong here. You have to adjust it. We cannot proceed, for example. So tossing is a way of sending a message to the user. So it contains a little message to the user and you can quickly communicate with the users. And the good thing is you provide a feedback to the user, either positive or negative. You might say, thing is completed now, you can go to the next step, we can press next. Now, the good thing is about it is it's give you this message and keep the activity of the app active and visible for the user so he can also interact with the app. It's not just displaying this message and everything will be disabled around you. No, the app will be still interactive for the user. Now, there is a steps how you can toss a message. You can work with the API of Toast by making a text. This is the method that allow you to create a Toast objects called make text, and this need parameters. Need this keyword, which is represent the link to the current application context, and also the text message that you would like to user see, and the duration of the toast message. This is an example. The text message, hello toast, and toast.length underscore short. So length underscore short is a constant from the toast class. It's defined inside toast class as a static variable to indicate the short period. We capture this and put it inside int durations. Now we define the toast message. Toast, the class data type, the name of the variable is toast, and then equal toast.makeText. So method makeText is called a factory method that take these parameters, these three parameters, and create a toast object and return it to the user. So make toast is called a factory method. It's create an object inside it and return it back to the toast message. So as you can see, the three parameter is there. This, which is referred to the application contents, the text that you like to see, and the durations. Then you press toast.show, which is responsible to show this message.
When you say application context, do you mean specifically the reference to Java files? Which Java files specifically?
There's no Java file here. This, do you know what this means? This use, when you are using this is a keyword. It's a special keyword. Let me just walk you through this, because this seems you are very confused. This is a special keyword on Java, and we already have some questions in the lab test about it. This is a special keyword on Java. Refer to what? If anyone can help us. When we say this, we indicate a Java file, a user APIs. What we are referring to this? Exactly. So what we are working on this?
Right, but like, if this is, let's say you have two Java files, you have one in the model, one in the...
There's no Java files here. There's no Java. This is referring to the object is being constructed right now, or the object that we are working on. So what is the object is now? Is the view, the application, the app view that you are working on. So you send this, all of it. It's like you sending, when you want to capture something from user interface, you send the view objects, and then you are able to communicate with the user interface. So this is represent the view that you are working with. Is the contents all of your application.
So this should be done in the control.
You're gonna see the example where I'm gonna take this part of code and put it in that. Okay? But this code is just to show you, this is a fragment of code to show you how you can create the message. What you need to create the message? You need the text, you need the duration, and you send this. This is the reference for object that you are working with now. Okay? This is the code. Now you will see where I'm gonna put it. Okay? If you like, I can take it, put it in the model. Then from the control, I call that code. I can take it, put it in the control. Okay? Doesn't matter where I'm gonna put it. The only thing that you need to know, these are the parameter is necessary to be given to the make text, which is going to retain an object of type toast. So this is the demo. This is the user interface where it's show you the XML. We have the buttons. It's called button short. And there's some parameters following to these buttons. And you can see when I click this button short, I'm going to go to the method called onClickShortToast. And this method, it will be defined somewhere in my app. This is the long, responsible to send a long toast message with the longer durations. And if I click on it, I will call another method. OnClick, long toast, which is a method is defined in my app. Now, this is the main activity class. Main activity is a class. Now, if you look at this main activity, there's three methods defined. And main activity is responsible to run and generate the user interface for you. And also, you define any control or any listeners on this main activity. Now this listener should listen to the user interactions and somehow call some methods. Now you can give, that is the opportunity, you can give all things on the control. I don't need to define anything in the model. Or in the control, I can just say, call this method. I define a class on the model, and then I call one method in that class. So don't restrict your mind. Whenever I gonna define everything, I'm gonna put it on the control, or I'm gonna put it in the model, sorry. No, you can choose where you're gonna put your code. But you have to understand the main activity is extended from an app compact activity, which is responsible to create the app. And the first method on create, there is another actions will be, but the only thing we focus here is on create. It's called the apps to generate the user interface based on the XML file that you generate. As you can see on the on-click short toast, we define the text, we define the length as a short, we call the method make text, and then we set the gravity of the toast message that we're going to discuss later. And then we ask to show the toast message. The same thing for long toast message. So this is the first activity, which is on create. It will create the app for us. This is the method, or what we call a listener. There is another way of defining a listener, but for this course, we take the simple and very direct way of defining it, because this is not a course where we discuss how you be a professional in creating the apps, as long as we need you to understand the Java code. So once the bottom is clicked, we have the attribute on a click. We call this method. Now, we decide to put whatever we like on that method. We could, on this method, define a new object and call some method on that object. The same thing for the on-click long toast method. And as you can see, we send the view. This here is represent the contents of your applications. So you send this as a reference to the toast. So this is a demo where you click the toast message, and as you can see, it's shown on the bottom of the screen, and this is the long message. In terms of the duration, the long message is more long than the short one. Now, there is a discussion about the gravity, whether you would like to see this message. The default will be on the bottom of the app, but you can change that. You can make the message to be appear on the top or to the left or to the right. So by set the gravity for the message. And this is the gravity. You say, I would like this message to be, for the short one, to be on the top, to the left. The long one, you set the gravity to the center, then to the left. And now you can see when you run the app, is different. This is the app for the code that we saw on the previous slide. When you click the short, you see it's on the top to the left, and the long one on the center to the left. So you can change the position of the message by setting the gravity of that message. Any question about the Toast API? I think you're going to use it on the D3. Okay. As I mentioned, we're going to start discussing the exception before we discuss the control. So the exception is it's never possible to predict what is the correct sequence of the executions of your program or softwares. So in that case, the program sometimes run on unexpected errors. And we as a programmer, we have to deal with these errors. Sometimes we need to terminate the program in appropriate state rather than leave the program run on the unexpected terminations, which is caused maybe the big failures. So rather than just saying, okay, I will terminate the program because I have run on unexpected event, rather than leave the program to run on terminations and catch this by the Java API, and that will crash your phone on the apps. You have to restart the phone. Exception on Java is an important instrument to signal something is abnormal is happening in the code. And once you have this signal, you can capture it, you can deal with it. Or even you can generate your own signals and define your own signal that you're going to see on next course. You can define your own exception, define your own signals for your app, and you can capture them and deal with them. So exception sometimes generated by your code or some external circumstances. Your code is not related to this exception. Maybe the machine or the cell phone that you are running the app is related to that machine. Maybe you run out of the memory on that machine. Your app is running correctly, but you run out of memory because there's a lot of app is running in the background. So we need to keep in mind for any public method that we have to verify all the preconditions is true before we run this method. So once you define a public method in your class, that means you allow everybody to access this method. And if there is any precondition for the input argument for this method, okay, you need to verify that these preconditions are valid. Otherwise, you might run an unexpected situation. Exception sometimes is fatal. You cannot prevent termination of your app. You have to terminate your app because this is happening. Sometimes things are recoverable. You can recover from the situations. You take the situations, there is abnormal activity is running on the code for your app, you can recover from this abnormal execution and continue. If you look at the exception tree inside the Java, you will find that everything is coming from object. Then we have throwable objects, and then we have two categories. The first category is the error, which is related to the system error. That is coming from the Java virtual machine. And this error describes the internal system errors. So if you have error in your code, then there is no way to recover from this error. The app should be terminated or the program should be terminated. The other part is about the exception. This exception is generated from your code or any external circumstances. As you can see, everything is inherited or taken from the exception objects. And we have many things here. Class not found exception, I think some of you already saw this. Input output exception, you're gonna see it when you handle either D4 or D5, when you want to work with input output files. And also we have runtime exception. Runtime exception, this is the one we focus here. Runtime exception, we have arithmetic exceptions and null operator exceptions, null pointer exceptions, and index out of bound exceptions, and illegal argument exception, and some other related exceptions. And this is only at a runtime, caused by the program error. So the compiler will not check these exceptions. Compiler will not be able to help you to find these abnormal situations. Only these runtime exceptions, the name is meaningful, runtime exceptions, so only occur at the runtime. At the runtime, you can see if you are referring to a null objects, or if you are accessing an array out of bound, you try to access out of bound array. Runtime exception, as I mentioned, is unchecked, and we focus on these arithmetic exceptions, null pointer exception, and index out of bound exceptions. Arithmetic exception indicated whenever you do arithmetic computations and you end up with exception, for example, divided by zero. You have two integer values and you try to divide by zero for two integer value, you end up with arithmetic exceptions. Null pointer exceptions, when you try to define an object of the class and you try to refer or use some attribute of that object, but still you're not initializing or constructing that object. So the object is still referring to the null. Index out of bound exception, when you define an array of index 4, for example, 4 element, and you try to access the element number 5, you are out of bound exceptions. So try to prevent these from happening in the first place, because you cannot find them. It's only happen at the runtime. So try to make sure the code is strong enough or robust enough so no such kind of exception is occurred. Null pointer exception is thrown if you are trying to access the object through the reference variable before the object is being assigned or constructed. Index out of bound, as I mentioned, when you try to access the element outside of bound of the array. Some fact about the exception: when the error is detected, the exception is thrown automatically by the Java, or you can throw it by yourself. Once the exception is thrown, you can catch it and print something, toss the message to the user, or ask the program to terminate, close that. Okay? So if the default handler is not provided by you, the Java will handle it by the Java virtual machines, and it will have some default handler for that exceptions. Now there is 5 keywords associated with the exception. Whenever we discuss an exception on Java, we have 5 keywords that we have to keep it in our mind. Try, catch, finally, throw, and throws. So all these 5 keywords are associated with the exceptions. This is an example of throwing, how to use and organize these try blocks, catch block. So you might have try a block and you open the braces and you put some statement. And these statements, you give a special attention to this statement inside try block. Special attention to these statements. Now, you can catch many exceptions from these statements. If the exception of type 1 raised, we go to the handle for exception 1. If exception 2 is thrown, we have to handle it on exception 2 part. And if exception n is thrown, we have to handle it on the exception n. So for each try block, you can have many catch blocks. Each one handle different exception. Now, in this slide, we see that how we organize try and catch block and finally block. Try, you put some statement inside these braces. You give special attention to this statement. In case of we have find not found exception, we're going to handle it on the first catch. That means this statement throw an exception of type find not found exception. We're going to go to the first catch. In case if no file not found exception thrown, but the I input output exception is thrown, we're going to go to the input output catch part. Otherwise, we're going to catch it with the common and general catch part, which is an exception. Any exception thrown from this try block will be catched on this part. The good thing about finally, it's always executed. Either you have exception or you don't have exception, finally block is always executed. Why? You might need in your app to terminate or close a connection to some database inside the try block. You open a connection to some external websites, some internet connections to external databases. Now you finish. You finish execution, or you have some kind of exception. So either there is an exception or no exceptions, always finally block is executed. And the purpose of this is to close any connections or destroy or terminate your app in the correct way. So we have a try. If we have a find not found exception, we're going to go to this. If we have input output, we're going to go to this handle. And if we have general exceptions, that we're going to go to this handle and we're going to run this code. Finally is always executed. Before we proceed, we discuss this rectangle class. As you can see on this rectangle class, we have private attributes, width and height, and we initialize them to 0, 0. And we have a constructor, parameterized constructors. We receive W and H, and we assign them to width and height. And then we have some get methods, get width and get height. And also we have get area, which is retain the area of rectangles. And we have also override toString. ToString is whenever we are using a rectangle object with a print statement, we're going to print this rectangle between the braces, width value and height value, and close the braces. And then we override the equals method. We're going to use it later on. So this class, we're going to use it as an example. We're going to use it later on. So in the equals method, what is the purpose of equal methods? We know that whenever we come across the primitive data type as an integer value, we say 5 is equal to 6. Equal, you can say no, because the value for this variable is not equal to the value of this variable. So this variable x is equal to 5, y is equal to 6, so they are not equal. But whenever we come to any defined object, you define it, you have to provide us with a way that we can make these two objects are equal or not. For example, this is one of the implementations of the equals. When I implement this method, I look for the rectangle in terms of what? Width and height. If the two objects are referring to the same object, that is the first statement. If this is equal to others, this means if both reference are referring to the same object in the memory, that means they are having the same address, I will return true. Otherwise, I will check if the other is equal to null or get class is not equal to get class of others. That means these two objects are, one of them is rectangle, the other one of them is circle. So there's no point of running the comparison right now, we return false. Now, if the other is actually have the same type of the class, so I will cast the other to rectangle because I receive it in the parameter list as an object. So I take the object, others, and cast it manually to rectangle. So it's now I look at it as a rectangular object. Once I do the casting, I will be able to ask if the rectangle got width is equal to the width of this rectangle, and also if the height is equal to the height. So this is equal methods. You can even, don't worry about it. You can just go to the Android Studio and right-click once you define your class, right-click and generate and ask him for generate an equal method for you. It will suggest for you an equals method. Okay, but I give you an example, this rectangle class, we're going to use it later on. And the way that I define the equals method is by looking to width and height. Now someone may say, okay, I don't care about the width and height. The two rectangles are equal if the area is equal. So in this case, in his applications or in his app, two rectangles are all equal by what? By the area. Let's say you define a chair class and you say the two chairs are equal if their weight are equal. So this is how you look at the equality. Say, oh no, the other students say, oh, these two chairs, I look at the equality based on the color. If they have the same color, then they are equal chairs. Okay? So the equality is depend on the program. In my rectangle class, I look for equality based on what? If the width is equal to the width and the height is equal to the height, I say these two rectangles are equal. Otherwise, these are not equal rectangles. Regarding the first two lines, this is about saying if you are referring to null object or the object that you are working with is actually is not the same class.
What specifically is
At override, this indicates for the user who gonna use my class that the equals is actually defined on a superclass. It's an object class. A superclass is an object class defined by Java expert, and this is not a scope for us, okay? Because this will be a scope of inheritance when you are covering the topic of inheritance, and the topic of inheritance is not topic in this course. So override is a annotation for Java documentations to let the user, I can skip it, I can delete it, okay? Nothing will be changed. Java compiler will not say anything. But I put it there to tell you that toString and equals are actually methods defined on a superclass. And this superclass is called object in this case. Otherwise, I can say extend the public class rectangle extend from some other superclass. But as long as I'm not saying anything, so any class you define it in Java is automatically extended from the object class. To know more about object class, just say Java object class and Google it and you will find more information. And if you go to the previous lectures, you will find the link where I provided to you to read more about object class. Any other questions?
Also, why do you write private if width equals 0 and equals 0 to just override that after?
When I say width is equal to 0 and height is equal to 0, so I'm initializing this attribute to 0. That's all what I do. I didn't create any object right now. I just saying these variables or these primitive values are initialized to 0. Okay? I'm not overriding anything. Once I ask the constructor to construct the object, I can only construct the rectangle by providing the width and height of that rectangle. And once I have the width and height, I assign it to the width and height of that rectangle. Okay? So, do you have any questions about this rectangle class? We're going to use it later on. Okay? So this is the constructor, this is toStrings, and this is equals method. So toString, if you didn't override this toString, that means you just print the address where the object is stored in the memory, but once you override it, it will be calling these methods. Now, if you try this an examples, I define another class called rectDriver, which is use the rectangle class. As you can see, on the main, I say rectangle A, semicolon. By the first line, I didn't create any object. I just say rectangle A will be a reference or be a variables of type rectangles. I didn't initialize it. Then I start trying to use it. The compiler will say no. You cannot use uninitialized rectangles. Now let us change this one to this example. So I say I'm going to define another method called public static, and the retain type is rectangle, and I call this initiate null, and there is no argument. The only thing I'm going to do is retain null. And I'm calling this method and assign whatever I'm retaining to rectangle variables, and then ask to print. The compiler will say nothing. This code will be compiled successfully. And there is a problem in this code. What's the problem? Can anyone suggest what is the problem? Where is the error will be? In the first statement or the second statement? Immediately, this will generate an exception, and actually runtime exception. We can see this exception once we run it, because this is not a compile error, not like the previous one. The previous one, the compiler was able to catch that we are trying to access uninitialized objects. Now, the compiler will not know that we have actually rect A is pointing to null. There is no object there. And in the second line, you try to get the area. You get area from what? From what? From null. That is where the exception we're going to see. This is the exceptions. You're going to see a null exception, null pointer exception. This is an example, really, when you are trying to access an object that is not being initialized. So the statement of printing is trying to get area of null object. There's no objects. I didn't construct any object on this examples. So you are trying to access some attributes, some behavior method, which is get area from that object is not initialized at all. Okay? Do you see that what is the null exception is? Any question? So you can throw the exception from your own method. So you can decide whenever you are come across unexpected situation for your app, you can throw the exception that you would like. Okay? And then you can catch it and handle it. So look at this one. This one is defining a method, a class called example1, and you define P method. And inside this P method, you are checking about the amount. If the amount is less than 0, you throw what we call a new exception. And if the amount is greater than 1,000, you throw an exception. And then you catch this exception. And actually, once you catch this exception, you throw a runtime exception. This is the example from the textbook, or somehow is modified example from the textbook. If you decide to throw the exception, which is the first class, you have to catch it. You cannot throw exception without the catch part. You can see here, we have a try block, and inside this try block, we put if statements. If the amount is less than 0, we're gonna throw exception. You know, the exception is the public and unknown. What kind of exception you are throwing here? Runtime exceptions or non-runtime exceptions? So you throw an exception. Once you throw exception, the compiler will not allow you to proceed without defining the catch part. The catch part will be catching the exception. The same type you throw. You throw exception, you catch exception. And inside the catch part, I throw another exception, runtime exception.
Can you create like a name for your exception?
That will be a topic of 2030. You create your own exception in your app. You inherit a class of exception, you create your own exception, and you throw these exceptions, your own exception. But tonight, in this course, we're gonna handle built-in exceptions, the exception that is defined by the expert. We're not gonna define our own exception here. But we can throw runtime exception with a meaningful message. For example, here we run a runtime exception, amount is negative or the amount is greater than more than 1K. I don't know what statement is causing the problem, but that is the problem here. I throw an exception, a generate exception without any meaning. So once I receive this message as a user, I don't know if the amount is less than 0 or the amount was greater than 1,000. Is that right? The only thing I know, there is an exception, a general exception. I can revise this code by throwing a runtime exception whenever I see the problem. So I can say if the amount is less than 0, I throw a new runtime exception. I give a meaningful message. You cannot withdraw with a negative amount. And if the amount is greater than 1,000, you cannot withdraw more than 1K. So you see the difference between the example in the top and the example below. So in the example in the top, I throw exception, a generic exception, and the compiler will ask me, you cannot proceed without catching the one that you generate because this is a common thing. But the one in the below, I generate a runtime exception whenever I need with a meaningful message. Now, if I receive an exception, I will know the source of this exception. It because the amount was less than 0. Okay? Okay, what do you think here will be printed? The good thing about programming is learn by examples. You will be able to use these tools of exception, catching, finally blocks by see these tools on actions on some kind of example like this slide. So we define x is equal to 0, y is equal to 5, and we try. Now, whenever you want to give a special care about your statement, you put them inside a try block. Okay, you put try block. You say, okay, this statement I want to be carefully looked for it, or special care about this statement. So if integer z you define is equal to y divided by x, and you print the result, and then you catch the exception, any generic exception. If there is any generic exception will be raised on this one, I will be able to catch it and then print a message to the user. And we have the finally part. So what do you think the output from this one? It will be an exception raised or not? As you can see, we're going to have a problem because we are trying to divide by 0 an integer values. 5 divided by 0. So in this case, we will have error message as divide by 0. This is the default message by the exception. And also we have a process complete. The finally part is executed. As I mentioned, the finally part or the final block is always executed, regardless if you have exception or not. In this case, we have an exception and the finally part is executed. Now I will be more specific. I will define A, B, and C and result and try to do some calculation, arithmetic calculation, and say, for this try block, if there is any arithmetic exception throw, I have to catch it on the catch arithmetic exception. And I will print exception divided by 0. That's the arithmetic exception that I'm going to count, or be more specific in my applications. And then I will print I am in finally block. So what do you think will be printed here? We're going to have an exception, and that's true. So we're going to have exception divided by 0, and I am in the finally part. So in these two examples, we have seen that the finally part is always executed. And in the first example, we are catching a generic exception, and we ask the generic exception to print the message. But on the second example, we be more specific that we are trying to catch an arithmetic exception. What about this one? We have the try part, and then we have the catch arithmetic exception, and then we have an exception, generic exception, and we have the finally part. What do you think would be executed in this one? Any suggestions? So we divide by 0, we will have arithmetic exception, and what is next? That is the good thing. So once the only one catch block will be executed. only one catch block will be executed. It's not on sequence. So once we are on arithmetic exception, because this is an exception is thrown by arithmetic calculations, so we're going to go to the arithmetic catch block and we're going to execute arithmetic exception. The next catch, we're not going to go there. Only one catch block will be, even you can have for a try block many catches, only one of them will be executed. But for sure, the finally will be executed. So in this case, we will have arithmetic exception and process complete. So as you can see, we are catching a specific exception, then generic exception, common exception, and then we have the finally part. But we cannot run the catch part on sequence. We run them based on the exception we see. So in case of the try block, raise an exception that is not arithmetic, then we're going to go to the next catch. In that case, a generic exception or a common exception. Now, what do you think here? We try to reverse the order. We say, I'm going to catch the common exception first, then a specific exception later, and then I will have finally. So what will be on this case? Yeah, the compiler will not allow you to proceed. The compiler will say, there's no sense here. The catch part should be organized from specific to generic, from specific exception to generic exception, not in the reverse order, from the generic exception to specific exception. The compiler will say, I cannot proceed with this. The logic that you are carrying and you try to program it is not valid. You cannot catch the generic exception and then go to specific exception. The order of the catch should be from specific to generic. Okay, so this program will not be executed at all. Okay, any question about the exception and how we can throw the exception and how we can catch the exceptions? Now we will start discussing the program control. But before we start program control, we're going to define what is an algorithm is. Algorithm is a series of actions in a specific orders. And these actions should be executed on the orders. Okay, that is the algorithms. Whenever you write an algorithms, you write. For example, each one of us has his own algorithm in the morning. How you start your day in the morning. You have to wake up. You have to pass to the Tim Hortons for sure. Okay? Then you have to come here. Some of you don't skip this action. Don't need the coffee in the morning. Okay? You prepare it at home. Okay? So you have a certain actions. You have to execute it every day on a certain order. Even your classes are organized in your schedule in a certain orders. Class after class, you have to go from this one, you have to eat your lunch, then another class. So everything is in orders. So this kind of algorithms, this kind of real life actions, we're going to take it and put it on the computer. And once we put these statements on order, statement can execute some actions. This is a kind of algorithms. You try to approach the problem in terms of proposing an algorithms. Now, the program control specifies the order in which this action is executed. For example, if you have a certain algorithm for every weekdays, but once you have come to weekend, you have different orders. So, yes, I have the same order, but in the weekend, I'm going to execute different orders. So, that is the same thing. You are running some actions, and you would like to control these actions. So some action will be run first. In case of we have some conditions, we're going to run some statements, some actions, or sometimes we need to repeat the same thing for a certain period of time. So a sequential executions or a transfer control. Sequential execution, very simple and very straightforward. First statement, second statement, up to the end of the problem. Control, no, you transfer the control by selection structures or repetition structures. So sequential, as I mentioned, statement 1 up to statement 3 and finished. Selection, no, you ask questions in your Java code, and based on the answer of these questions, either true or false, you're gonna run different statements. So either statement 1 or statement 2 will be executed, not both. We cannot execute both statements. If you would like to execute both statements, put them in sequential order. But now once we have a selective structures, so one of these statements will be executed based on the decision, either true or false, or conditions. So the sequence of execution, you can add the grade to the totals, for example, and then you increment the counter by 1. These are sequentials. There's no conditions here. Controls, we have if statements that help us to control the flow of actions, if-else statements, switch statements, and also we have a repetition structures that help us to repeat a certain action for a period of time or a certain amount of time. So while, do while, and for loops. And each of one of these is a keyword. So if is a keyword, if else is a keyword, and also switch is a keyword, while is a keyword, do is a keyword, while is a keyword, and for is a keyword. All of these is a keywords. You cannot define an identifier as while. Before I jump to discuss, I will just remind you about a rational operator, which is greater than, less than, greater than or equal, less than or equal. Equal, which is now not for assigned variable. This is for equivalency. You want to check if these two items or two variables have the same value, or two rectangles are equivalent. As you saw in the previous example, the two rectangles are equal if their width and height are equal. Not equal. So the result of all of these rational operators either true or false. Take half a minute and give me the result of this. Okay, so the first statement, we define P is equal to 2, Q is equal to 2, R is equal to 3. Then we create a new integer object. So I and J are not primitive data type. They are object data types. So the object I carry the value 10, and the object J is carrying the value also 10. But both are objects. Now, if P is less than 3, what will be printed? True. P is greater than 3, false. Is P equal to Q? P is not equal to Q. What about the last thing? I is equal to J. And I is not equal to J. The last two statements you answered wrong. I is equal J is false. Why? Because I and J are objects. So when you define I, you go to the memory, you reserve, put I in a certain address. J, you create object, you put it in another address. When you say I is equal to J, really you are saying if these two objects are in the same address in the memory. And that's not true. Because I in a different space and J in different place, so they are not in the same address. So the equality for objects, look at the address. They are not looking about the internal state. So what is the internal state of I? Is 10. What is the internal state of J? Is 10. But I'm not looking for that for equivalent. When I say I is equal to J, I say for the Java compiler, are these j and I are on the same address on the memory. So it will retain false. But if when I ask if I is not equal to j, yes, that's true because they are two different. Yes. No. Yeah. The difference is what I said. I equal j is look for the address. Then you have to ask if integers class implement equals method as I show you in the example of rectangle. In the rectangle, I implement equals method. So I can say I dot equals, I will execute that method, I will send j on that method, and I will see if they have the same value or not. So whenever you are using equals method, you are trying to see if these two objects, the state of these two objects. But the question for you is not clear because you might have object and you didn't implement equals method for that object. For example, if my class for rectangle, I didn't provide or override the implementation for equals, the default behavior for I dot equals or rectangle dot equals will look for addresses. It will be the same in that case. So I cannot answer your questions. I have to look at your code, then I can say if equals equivalent to dot equals. Because dot equals will be the same as equal if you didn't provide the implementation for equals. But in my case, when I define a rectangle method, I decide as a programmer to go deep and re-implement the equals methods. So whenever I say rectangle A dot equals rectangle B, it will return a true only if both rectangles have the same width, the same height. But if I didn't provide anything, then when I say rectangle A dot equals rectangle B, we look for the addresses. Will be equivalent to equals. You see that? So the actual behavior for equivalence, when I say I equal to J, let us focus on this example. I'm looking for the addresses. If these two objects are on the same address or not. Okay? If they are on the same address, then I will return true, otherwise I'll return false. Any other questions?
So how can I make the I and J like the same address?
You do the assignment. Yeah, like you say I equals J, and you're gonna see that later on. In that case, you make I and J referring to the same objects. Okay? Okay, so we'll start with if select statements. So it's single entry points and single exit points. It's perform the action if the condition is true. We're gonna go quickly over this. If the condition is true, I'm gonna execute the statement. You cannot write the condition in Java without the parentheses. The parentheses are mandatory. The compiler will reject the statement. If condition without the parentheses, compiler cannot complete. So you need the parentheses. So this is F, is a reserved keyword. You have the conditions. Inside the parentheses, you have the statement. As long as you have only one statement, you don't need the braces to create a block. If you have many, you have to put the braces. So if the condition is evaluated true, we're gonna run this statement. Otherwise, we're gonna go without running the statement. So if the student grade is greater than or equal to 60, I'm gonna print this message. Otherwise, I will not print this message. If you have multiple statements, like statement 1 up to statement n, you have to include inside the brace block. So you want to say to the compiler, if the Boolean expression is evaluated to true, run statement 1 up to statement n. Otherwise, skip all these statements altogether. Just to recall the logics, you have the logic operator and, or, exclusive or, and you have logic not, which is the negations. This allows you to create more complex compound logics. Let's see. So if you have expression 1, expression 2, and you want to say and between expression 1 and expression 2, you are saying only these statement will be executed if the expression 1 and expression 2 are true. Otherwise, will not be executed. Or is the difference that you are saying as long as one of these statements are expression are true, you execute the statement. Otherwise, you have to skip only if both of them is false. If both statements are false, then you have to skip the statements. Now, exclusive OR, which is the one that you're gonna run only if and only if one of them is true. If both are false or both are true, you're gonna skip because the evaluation for exclusive OR is false. Negation is the opposite. If the condition or statement or expression, is false, you're gonna execute. If the expression is true, you're not gonna execute. This is an example. So in this example, what exactly we're gonna execute? If x is greater than or equal to 0 and less than or equal to 10, this will be executed and this will be inclusive between 0 and 10. This is the Boolean expression, the first Boolean expression. I less than or equal to 10, the second Boolean expression, and you make and between them to generate one compound expression. If else statement, you will decide on the previous slides we saw that if the condition is true, we're gonna run a statement, otherwise we're gonna exit without running any other alternative statements. Now, in case of if else, perform action if the condition is true and perform a different actions if the condition is false. And there is a shortcut for if else statement, which is called a conditional operator with a question mark and colon. Else clause can be added to if statement, and that will create if else statement. So you can see here, if the condition is true, we're gonna run statement 1. If the condition is false, we're gonna run statement 2 and then exit. So one of these statements will be executed, not both, based on the conditions. So if the condition is true, we're gonna execute statement 1, otherwise we're gonna go statement 2, then exit. So one of these will be executed, not both. If the condition is evaluated to true, I'm gonna run statement 1. If the condition is evaluated to false, I'm gonna run statement 2, then exit from the execution. In this example, you see that a student grade is greater than or equal to 60. I'm gonna print pass. Else, I'm gonna print fail. So here we have two conditions. This else statement is actually by default does not require a condition. Why? Because it's a complement of the condition that for if statement. So in this case, the if statement is greater than or equal to 0. What's the complement of it? Less than 0, 60. So greater than or equal to 60, the complement for greater than or equal to 60 is less than 60. So the condition for else, it's already defined by the condition of if. It's a complement of that condition. This is an example. If I have radius is greater than or equal to 0, I'm gonna run through some calculations and print statement. But in case of there is a problem with the radius, and the radius was the complement of this condition, which is radius is less than 0, I will run as a negative input, and I'm not gonna execute the calculation. As you can see, the if statement contains multiple statements. So we include it inside the braces block, and else contains only one statement. Again, you can have multiple statement for if part, and you can have multiple statement for else part, but that require from you to have the braces, open and close the braces. This is an example where we have a Boolean expression and we have statements. If this expression in case of a true, multiple statement, and we have the braces. Now, even if you have one, you can have the braces open and close, but people for one statement, they are not doing this. Only in case if you have multiple statements. The conditional operator is very short cut and sometimes written in one line, and some people they are recommending to using it in case of a clear expression. So you have Boolean expression, you ask the condition for Boolean expression. If this Boolean expression is evaluated as a true, you're gonna run expression 1, otherwise you're gonna run expression 2. So you have the expression 1 if the condition is true, expression 2 if the condition is false. For example, you can write if-else statements, print the one that we saw in the previous slides, system.out print line, student grade greater than or equal to 60, then you ask question mark. If that's true, you're gonna print pass or retain a string pass. If this is complement or false, you're gonna retain fail. This is an example for 1, 2, 3, 4 lines of code can be written as a one line of code. You see, if x is greater than 0, you're going to assign 1 to y, else you're going to assign minus 1 to y. You can combine all these statements on one statement using conditional operators. You say y is equal, and then you ask the questions. If x is greater than 0, and that's true, you're going to retain 1, else you're going to retain minus 1. Any question? Okay, so this is the test. F, this is retain if it's true, and this retain if it's false. Okay, test your knowledge. What is will be printed here? What's the first line printed from this code? True. The second is 1. If you ask question, if f is true or false, f is false, you're going to retain 2. So you can see now conditional operator is very useful to compound the codes. Rather than writing multiple codes, you can write them in one line of code. Sometimes you need what we call if nested if-else statements. So you need to ask multiple questions, and at each level you ask different one. For example, here, if the student's grade is greater than 90, this is the first condition, and you print A, capital. Else, what is the complement of greater than or equal 90 is less than 90? You say, okay, for that part, I will ask another question. If the student's grade is greater than 80. You see here, it's only one print statement will be executed, not all of them. This is not a sequential execution. So either you print A, B, C, D, or F. You cannot print all of them because when you go to the else part, you go to the complement of that condition. So greater than 90, the complement is less than 90, and then you ask questions if it's greater than 80. Now, if that's not true, you go to the else. The complement of 80 is less than 80. You ask 70 and you ask 60, otherwise you go to the complement. So the last else statement is the complement of the if statement, the one before it. So it's greater than or equal to 60, so the complement is less than 60. Okay? Do you understand if necessary statements, how it's work? Any question? Okay. So this is an example to determine if the input is positive or positive even integer. You can see here, this is a textbook example. You can see some implementation. This is the first implementation. You define Boolean result as equal to false. Then you ask the first question. If x is greater than 0, I'm going to go inside. Otherwise, I will retain result. In this case, I will retain false. So the integer value is negative. That is the complement. Otherwise, I will go inside. The x is greater than 0. I will ask if x is modulus of 2 which means is divisible by 2 is equal to 0, that is the even number. If you take any even number and divide it by 2, the remainder is equal to 0. And this will retain true. So you can see this is one implementation for is valid by checking two if statements inside each other. So defining the result, then check if statement and retain this. We change the implementation. We say we can replace the previous implementation with one compound if statement with and. So you can see here we have a combined expression. We have Boolean expression if x is greater than 0. If this is a true and x remainder by 2 or modulus of 2 is equal to 0. So you have two Boolean expression. If both Boolean expression is evaluated to what? To true, then you can execute the X statement retain true. Otherwise, you retain results. Someone say, okay, I will provide another compound and efficient implementations with one statement. I will say, retain the Boolean result from this compound expression. If x is greater than 0 and x remainder of 2 is equal to 0, this will be validated to true. That means this x is greater than 0 and it's even. So I will retain this statement. As you see in the previous 3 slides, we are implementing the same method. And we have used if-else statement or if statements as a tool to provide different implementations, okay? And I am sure if I ask you, give me a fourth implementation, you can come with another unique fourth implementations. So the implementation for a single method is not unique. Each one of you will implement it on different way. You might have 2 or 3 students, they implement the same thing, but you might use a conditional operator in this case, or a nested conditional operator in this case, okay? A repetition statements, we have repetition statements like while, do while for loops. So the first one is while loop. You repeat an actions while the action is true. Otherwise, you're not gonna go inside the loop. You're not gonna execute anything. You're not gonna repeat anything if the condition of while loop is false. See this in action. While the product is less than or equal to 1,000, I'm gonna keep multiplying. So the statement product is equal to 2 times product will be keeping executing, and I'm checking the product value at each iteration. Each iteration, I'm check if the product is less than 1,000. So the condition is start by while, and then if the product is less than or equal to 1,000, I'm gonna go double the product, and then go to the merge node, check the condition again. If the condition is false, I will exit the repetition. So the statement, you see here, the one statement need to be repeated as long as the product is less than or equal to 1,000. Okay. What do you think the output of this code? While you define the count is equal to 0, and then you ask while the count is less than 4. I would like you to notice here that this is the first line you see on Java without ending the semicolon. While you open the parentheses and you say count less than 4, and we didn't provide a semicolon at the end. Okay, this is one of the lines that you're going to write in Java without ending with a semicolon. Okay? And then you open the braces, you provide some statement, welcome to Java, you print the count, and then you increment the count. So one of the conditions here, you put the initial value for the count outside the while loop, you check the count, and inside the while loop, you're changing the value of the count. Otherwise, if you remove count plus plus, this will be executed forever. No one is changing the value for count, and this will be an infinite loop. So this will print 4 times, starting from count is equal to 0 up to 3. Now test your knowledge. What do you think the output from this one? First, we define the initial value for numbers is equal to 1. Then we go to the loops and we print something. What do you think we're going to print? What will be printed? Yes, up to what? What's the last one? Then give me the last one. 200? The last one is 128. So this is the output of this code. Any question? So the component for the while loop, the initial value, that should, in this case, the number, we initialize it, and we check the number, and inside the while loop, we keep changing things, because we need to make sure this while loop would be terminated. Okay, what do you think here? What's the output? There is no output. Why? It's already 7. So 7 less than 7, that's not true, because 7 is equal to 7. So this loop, condition for this loop is evaluated to false. So we're not going to go inside the loop at all. So there's no output. Condition is false. Okay, what about this one? Yes. Yes, so this will be an infinite loop. So you can see we set count to 2. The condition is true, so we are inside the loop now. And we are inside the loop forever. We're not going to get out from the loop because no one is changing the value for count. So in this case, we have infinite loop. And this infinite loop should be avoided. Okay? Some fact, infinite loop, the body of the while eventually must make the condition false. So whatever you ask while condition, inside the body of the while, you should make this condition false at a certain iteration. If not, then you end up with infinite loop, and this is a common logic error. Compiler will not take this, okay? And you should always double check for a logic error in terms of while loop, for loop, or do while loop. So whenever you are using the repetition statement or structures inside Java or any other programming, you have to double check to make sure this loop is terminated successfully. For loop or for repetition statements, this combined many things in one line. It's take care of initialization. As you compare to the while, you have to do it outside. You have a semicolon, not a colon, semicolon. Then you have a condition in the middle, and you have increment at the last. So you have 3 parts, initialized, and all these parts are optional. That is the good thing. The compiler will not check it for you. So all these 3 parts you see here on the for loop are optional. I can provide a for loop, open parentheses, semicolon, semicolon, finished. It will run forever. But you can initialize, you can check for the condition, and also you can increment the conditions. So this is the structure of for loop. Initialization, loop, continuation, conditions, and increment the statement. This is exactly match the while loop. So if you take the for loop, all these one statements to be end as initialization outside the while loop, loop conditions inside the parentheses, and then a statement, and you can see here on the while loop, the increment should be the last one. Okay, the increment should be the last one, or you would like to put it in the beginning, it's your choice. So this is the initialization. Condition is evaluated to true. You're going to run the statement, update, go back to the conditions. So this is the structure of the for loop. So you initialize the counter to 1. You ask if the counter is less than 10, execute some statement, increment the counter as a part of the loop, and return to the merge node. Examples. Using the for loops, you can generate a variable from 1 up to 100 by increment by 1. Or you can generate, using the for loop, a variable that is changed decrement by 1. So change starting from 100 into 1. Or you can create a variable, that is the beauty of the for loop. You would like to create a variable, and inside your code, the value for variable is count by 7. You can do that using the for loop. So you can write this, for loop int is equal to 1. As long as I is less than or equal to 100, you increment I by 1. So inside this for loop, with this header statement, I is taking the value from 1 up to 100. So we run this for 100 values. Now, to decrement, we're going to say integer I is equal to 100, and then as long as I is greater than or equal to 1, you keep decrement by 1. Count by 7, you start I by 7, and you add I by 7 as long as you are less than 77. So, the good thing about for loop is it's the power of repetition and creating a variable in different orders. Do you have any question up to now? Sometimes some implementation or someone asks you to move from for loop to while loop implementations. So moving from while loop to for loop or in reverse direction from for loop to while loop is easy. You start by putting the initialization outside, then the condition for the while loop statement and increment. That is the match the for loop, because increment always the last statement of the for loop. Some fact about the for loops. Each expression on the header of the for loop is optional, as I mentioned. You can define a for loop without initialization, without condition, and without increment. The initialization is to the left out. No initialization is performed. If the condition is left out, then there is no conditions. Therefore, we are creating an infinite loop. If the increment was left out, there is no increment is performed. So all these 4 parts of the for loop are optional. So for example, this is a for loop. It's a valid for loop. I'm going to do something for infinite. Okay?
So it's optional. If you put the incrementation inside loop, will it still go into infinity?
Yes. You do something, then this is an infinite loop, but inside this statement, do something, you might break out. We're going to see some things on the next slides about break. You can use the break statement to break out from any loop. This is exactly match while true, do something. So you are saying while it's a true, do something. Now to break out, these both are infinite loop. To break them out, you have to use break statements. Now this is an example from the textbook to retain the largest factor of a given positive integers. What do we mean by larger factors? What do you mean by larger factors? Even if you don't know what is meaning of, by looking to the implementation, can you tell me what is it? What is the largest factors? I don't know what is it in mathematics. I forget totally about it. But by looking to this implementation, I can know what is it. So what is the largest factor is? I start, look for the largest factor. Any integer value on the reality is divisible by itself or by 1. Take 100 divided by 1 is 100. The remainder is 0. 100 divided by 100 is 1. The remainder is 0. That's why we say a divisible. So the largest factor is the largest divisible integers exist on this range. That is less than the number. So greater than 2, because 1 is already divisible for any number, and the number itself is already divisible by itself, so there's no problem. So we are executing the loop from I is equal to 2 up to I less than n, not less than or equal to n, less than n. So let's say I give you 7, I ask you to trace the execution and give me the result. So what is the result if I is equal to 7? n is equal to 7. What is the result? Trace the execution and give me the result. So we keep checking if n is less than, the remainder by dividing by I is equal to 0, and then we set the result to I. If n is equal to 7, the result will be equal to what? 1. Okay? If n is equal to 12, what is the result? Yeah, good. So this is another example from the textbook to retain log 2. This is a very mathematical operation, so you rely on your calculator to find log base 2. 8 log base 2 is what? This is how the programming come to real life situations. In the real time situations, we used to have pencil and papers and long tables to calculate the log base 10 or log base any numbers. We have to look at the tables and make sure the value divides some value and pencil and paper. This is a problem in real time, and we take it and we create an algorithm. This implementation of this method is really, this is what we are looking at the end of the semester, by giving you a real life problem and ask you to give me the implementation, like what we have in the lab test 1. I give you the PDF, the normal distribution. I give you the formula. It doesn't matter, you need to know it's a normal distribution probability. You need to implement this formula. That's what I want you to do. This is a mathematical expression. Give me the implementation for this mathematical expression. Multiply, calculate the Euclidean distance, for example. So this is a log base 2. And this is also log base 2. The first implementation using for loop, the second one using while loop. Test your knowledge. What is the output of this one? Error? Why? We mentioned that the initialization part is optional, so we can skip the initialization part. We have the condition as long as I is less than 10, we increment, otherwise we don't need. So the value is what? I is equal to 10. Why? Why? Yes. Exactly. We have a semicolon at the end of the for. So the loop will immediately finish after we increment. And we mentioned that the increment is the last thing we're going to execute. Okay? Good? Pay attention to all details. Do while loop. Do while loop, sometimes you need to do something before the checking. As you see, all the things are happening. The previous one is actually like do while loop. We go to the loop, then we check the condition and we increment and then we exit. But do while loop give you one iteration for sure. That is what's the beauty of it. Do something, then check the condition. If the condition is okay, redo the something again. But If the condition is failed, you're gonna exit. So do while loop give you one iteration. Do the action, check the condition. If the condition is okay, you're gonna go back to actions. Otherwise, you're gonna go out. Comparing between while and do while loop, you can see the difference. The condition at the beginning in the while loop, if the condition is true, we're gonna execute the statement and continue. But in the do while, is the opposite. We're gonna execute this statement, and if the condition is true, we're gonna go back. Otherwise, we're not gonna go back to that statement at all. So this is a knowledge test where you have a counter is equal to 1, and then you go to the do while loop. What do you think would be printed here? What's the last value? Okay, so the last value is 128 because we have to do the statement before checking the condition. So we're not going to stop at 64. 64, we're going to check. 64 less than 100, that's true. We're going to go back to the do statements and count, multiply by 2. 64 divided by 2 is 128. Now we check the condition. The condition is 128 is not less than 100, so we exit. So we have one iteration extra in this case. What's the output in this case? 100. It's only gonna printed 101. Okay, because we have one iteration guarantee. Any question? Okay. Switch statement is another alternative choice for you for if-else statement, but you have to follow the rule of if statements because if statement does not take the Boolean expressions as a conditions, either integers or a character, either to say integer equal to 10 or character is equal to y. You cannot use Boolean expression to check the condition of switch statements, okay? So that is the thing about Boolean expression. The only Boolean expression you're gonna get is equality Boolean expression, but this is already implicit for you. You cannot perform a rational condition on the if switch statement. So all multiple case without the code indicate the same thing, doing the same action. We're gonna see examples on this. So switch, you give an expression, and this expression, if equal to value 1, you're gonna run the statement listed 1. If the expression equal to value 2, is not if it's true or false. The expression here, it's an integer value or a character value. So if the expression value equal to value 1, you're gonna execute the statement belong to value 1, and then you go outside. Then if the expression evaluated for value 3, you're gonna execute the statement for value 3. So case A, if it's true, we're gonna go to run some action for case A and break out. The same thing for case Z. If the case Z is true, we're gonna run some action for that case and then break out. So the break statement is used as a last statement on each cases to break out from the switch statement. If the break statement is not there, then the execution will be sequential, and that is the thing about the switch statement. So you need to put cases, and at the end of each case, you put a break statement. The break will tell the compiler, I have to break to the out from the switch statement. Otherwise, we'll execute to the next state or next case. So this is an example. You ask for a category. Category is an integer value. You ask if the category is equal to 10, then I'm gonna run this one. And you see a break. I'm gonna go outside. Otherwise, I'm gonna go to case 9. If the category is equal to 9, I'm gonna print a statement and then break out. In case of you don't have case 10, 9, 8, 7, and 6, you have a default case. Then I will print the default case. You see the break statement to tell that to break out from the case. Default in case of you don't have any match case statement. So learning by examples, you have here three counters, A, B, and C counters, and you have a car A, and then you say switch car. That is one of the valid things about switch statement. Either you have an integer variable or integer expression, arithmetic expression and evaluated as an integer, and you ask, if the case is A capital, I'm gonna increment the A counter, then break out. If the case is P, I'm gonna increment the P counter and out, and case C and out. As you can see in this switch statement, I don't have a default case. That is okay because default is an optional. What is the output from this one? Which counter will be print incremented? A counter. So what's the value will be? 1, 0, 0. Is that right? Okay. Let me change it to this. What's the difference between this one and this one? For each case, I remove the break statement. So what's the behavior in this case? Is a sequential. So now the switch statement is actually useless because we're going to go to the case A, then follow that case B, follow that case C. So what's the output? 1, 1, 1. All these counter would be incremented because there's no break statement. If you remove the break statement from the case, then you do the sequential execution. Okay? Now, no break statements. Now, what about this one? Based on our previous discussion. Any suggestions? Yes? 1, 0, 1, 1, 0. So A counter will be incremented, B counter will be incremented, then we have a break statement. Break statement was what? Break the execution and go outside the execution. Yes? Yes, it's one check. What is it? I don't loud. I can hear you. So yes. No, you go to the case A. Now you are executing A counter plus plus. You are there. You execute sequentially. Did you see a break? No. So the case B is not executed at all. No, look at this example. The switch statement is useful if you are using it in the correct way. You have to add the break statement. This is the cases. You ask if the value is A, you go to the case A, you execute some statement, then you break out. It's your responsibility as a programmer to break out, not the responsibility of switch statement to understand that case B is not valid at all. Execution will be sequential if the break statement is not there.
Just to clarify my point, let's say you change the character to B, right?
If you are in B, then I'm going to go to the case B. I'm not going to go to case A. In this case, counter A will not be incremented. You see where is the switch is going? If you change the example, that's a different example now. If your character is B, you're going to jump to case the switch. It will ask, what is the character? The character is B. Then I go to the case B. You see, the first statement I already skipped. The execution start from P count is plus plus. We'll increment the P count, and then the next statement's break will be out. Okay? So some facts about the switch statement. So the switch statement has a default case optional. And if the default case is not it's gonna be executed if there's no association of any values. So you can go back to this example and let's say change it. Do that implementation by yourself and change the character to D and see what will be executed. Okay? In that case, if the character is equal to D, you're gonna go to the default statement. Okay? If there is no default statement and no other value, then the control will be falling out that switch statement. Now, we saw the infinite loops, and we saw that sometimes we need to break out from the infinite loop or break out from the loop if some condition is valid, or we need to continue next iteration. So we have a break statement and continue statement. So the break statement will immediately exit from the loop. Continue will skip one iterations. Continue will skip one iteration of the loops. Let us see these in actions. Let's say you are running a for loop from x is equal to 1. If as long as x is less than 10, you increment x by 1. If x is equal to 6, you're going to break out. Otherwise, you're going to print a statement. So what will be the execution of this one? So we're going to go x is equal to 1, that's okay. 2, 3, 4, 5, then 6. When x is equal to 6, we're going to break out. Break will break out from the execution and stop the execution. So we're going to end up by printing 1 up to 5. The situation is opposite when the continue is used. The continue is a skip and iterations. So you are executing from 1 to 10, and if x is equal to 6, you're going to continue. So that means you skip the iteration of 6. You're going to continue to x is equal to 7. So you're going to see you print from 1 up to 5, and once x is hitting 6, you're going to ask continue. So all the thing will be skipped, and a new iteration will be generated. So that means will not terminate. So these two examples show you exactly what's the difference between break and continue. Forever loops. These are loops that are executed forever. So you have to add a Boolean expression with a break statement to break them out. Otherwise, you will end up inside an infinite loop. The same thing while true. This is an infinite loop. You add a break statement to exit from these four loops. Otherwise, the loops goes forever. Nested loops. As we saw nested if statement, we have nested for loops. So nested for loops, this is an example. For each iteration from outer loop, the inner loop will execute completely. Keep this in your mind. For any iteration of the outer loop, the inner loop will be executed completely. So in this case, count 1 is equal to 1, and count 1, while the count 1 is less than 10, and we add the count 2 is equal to 1, and we are running inside 2 while loop, nested. So how many times here will be printed? Any suggestions? So for each iteration from outside loop, the outside loop will run how many times? 10 times. The inner loop will run how many times? 20. So for each iteration from outside loop, the inner loop will run completely. So 10 times 20. So this will run 10 times 20, 200 times. What about this loop? I started from 1. How many times? We're going to print star. So this will print, because the inner loop is counted by j less than or equal to I. An exercise for you to the home. This if statement, this is nested if statement. Try to convert it to switch statement. Okay. Exercise for you. What is the output from these loops? Exercise for you, what is the error on these loops? Okay, test your knowledge. To convert this for loop to while loop, how we can do it? And then
First initialize the variable I, so 1, and then you say, well, I is less than or equal to 10, you output high there, and then after that you increment I.
I increment should be the last one, not the beginning. Okay? So this is exactly what you see in the slide. Initialize I to 1, check I is less than or equal to 10, you print I there, and you increment at the end. How many times this loop will be executed? Five times, one time, four times. You have to be able to trace the execution, either give the output or determine how many times each loop will be executed. So these exercises for you, generate a for loop that print these numbers. Okay. Test your knowledge. How many times the loop body will be repeated? Any suggestions? Okay. This is the answer. I encourage all of you to go to these examples and exercises and try to change them and try to see different possibility for different output. First, try to run these test knowledge or the examples and do the exercises. Okay. Nested for loops. What does this for loop print? As you can see, integer I is equal to 1, and you have the inner loop. This will print 2, 1, 3, 1, and 3, 2. Okay, just a couple of slides. So I will leave these slides just for your knowledge, for you to practice them. The only thing that you can practice and be master of if, else, switch statements, also for loop, while loop, do while loop, might see them on action. That is the first things. You see examples, how they are used by other programmers, and also how you are using them. If you are not using while loop, you have to know how to use while loop. Sometimes, as a programmer, you have to master some loops. For example, for loop. I'm using everything using for loop. But this is not enough for this course. You have to be able to use for loop, while loop, do while loop, and move between them. If I give you while loop, you have to give me the for loop equivalent to it. If I give you while loop, you have to give me for loop equivalent to it. Or if I give you for loop, you have to give me do while loop equivalent to it. Okay? You have to be able to move from one iteration to another iteration or repetition statement. Okay?